Hello and welcome to This Week in Engineering, brought to you by Engineering.com.
This week, we're doing something a little different and taking a special look at the bizarre world of quantum computing.
Quantum mechanics explains a great deal, like why hydrogen in a star emits a certain frequency of light. But it also describes some weird situations. For instance, quantum mechanics proves it's possible for a particle's spin to be in two states simultaneously, up and down. If you measure the spin, you get an answer, up or down. But if you don't, then the particle acts as if it were in a combination of both the states at the same time. This combo trait is called superposition, and it's kind of like my broken sink. Maybe I'll fix it myself. Maybe I'll call a plumber. I could go either way. But ask me one more time, and then, fine, I'll call a plumber. Are you happy now? See, by asking, you forced me into a state, dear.
And that brings us to animal cruelty. Regarding superposition, Erwin Schrödinger said the same thing we all did. WTF. But more eloquently, using a thought experiment, he proposed sealing a cat in a box with a mechanism that would either kill the cat with cyanide gas or not, depending on the particle's state. Schrödinger said that with the box closed, the state of the particle can't be observed and therefore exists in both states, concluding that the cat simultaneously exists both alive and dead. Spooky. But wait, can't the cat measure the state of the atom, thereby forcing it into one state or the other? Well, that's the point of the paradox. Either way, I say the cat is a zombie. I've seen what cats do to the birds on my doorstep. They eat brains.
And that brings us to qubits, or quantum bits. In a classical computer, information is stored in bits, which are either 0 or 1. But in quantum computers, we use particle spin that could be simultaneously 0 and 1. As long as we don't measure the spin, the particle is in both the happy cat and zombie cat states. With classical bits, 3 bits are combined sequentially to make a total of 8 states, but 3 qubits can make all 8 states at once. Now imagine a computer with hundreds or thousands of qubits. That system is so complex, it can't be modeled by a classical system. Surprisingly, there is such a thing as too many zombie cats.
That never gets old. How could you use quantum computing? It may allow faster searching and comparing by using qubits to test several possibilities in parallel. But another field is cryptography. Most encryption algorithms in use today rely on the fact that splitting a large number into its prime factors takes almost exponential time. But with a quantum computer, Shor's algorithm will complete the task in polynomial time. So, with quantum computing in the wrong hands, your documents, even with strong RSA encryption, are hackable. You'd think that Homeland Security and NSA would try to stop quantum computing, but in fact, they're actually funding the research. Probably because they want to read your encrypted documents and emails. Where's my tinfoil hat?
If you think superposition is weird, get a load of entanglement. It's possible to link 2 particles to the same quantum state and make them entangled. Then, you can separate the particles, and whatever action you perform on one of the particles instantaneously happens on the other. This means quantum information travels faster than the speed of light. Also, it can't be intercepted. Einstein called this spooky action at a distance, and he didn't believe it would work. Whatevs. I say, if you want to give your armies on Mars the attack signal without the Klingons hearing you, give them a set of entangled particles before they leave. Take that, radio communication and Navajo wind talkers!
One of the major problems to building a working quantum computer is called decoherence. Apparently, when you store data inside a single subatomic particle, that data is really frickin' fragile. Any vibration or stray electromagnetic radiation, and your data is corrupted. We need to develop technology to reduce the likelihood of a corruption, and also what to do to detect it when it happens. I know a thing or two about decoherence. Do you know how many times we filmed that last story?
This means... I almost made it.
Seriously, Dan,
So where is quantum computing today? Canadian firm D-Wave has a device that they claim is a quantum computer, though experts remain skeptical. The D-Wave 1, which comes with a refrigeration unit to cool the qubits down to an amazing 20 millikelvins, has been used by Google to research a super fast way to search images using Grover's algorithm, and another was sold to Lockheed Martin for undisclosed purposes. Other machines are being researched, the most promising ones using trapped ions manipulated by lasers. The research is ongoing for both the algorithms and the hardware, and frankly, it's starting to feel like the Arrested Development movie, always just a few years away.
Feel like you understand quantum mechanics? Then you, my friend, should stop taking hallucinogenic drugs. They're bad for you. But if you'd like to learn more about quantum computing, try following some of the cool links we've provided. It's a much better use of your time than devising elaborate executions for your pets. Do you expect me to talk? No, Mr. Mittens, I expect you to die.
This week was a little different, so tell us what you think in the comments section. Or if you like the show, hit the freaking like button already. Well, that's it for this week. Now, get back to work.